then you will find the behavior of the solids. That is altogether different thing. This is not what you will find if you apply your laws directly on the output. Right? Yes. If you go inside the polycrystal, there are individual crystals. Okay? Yes. So now, a grain is a polycrystal. You go inside a crystal. What is there inside the crystal? It is a particular atomic structure, BCC, FCC, etc. Yes, sir. So if you go further, there is an individual crystal. How the crystal structure is formed? What are the locations? There are some dimensions in the crystal structure. Yes, sir. There are different dimensions. Right? So how to find out those dimensions? Dimensions of that particular crystal structure. You have to go into atomic physics. There are some equations there, van der Waals force, other force, some potential, etc. Okay. So there are stress and strain even for a crystal, even for two atoms when you are analyzing atomic physics. Okay. There are distance, there are force. So this stress and strain, they comes from the atomic level also. That is also possible. So this is what is meant by continuum mechanics and computational mechanics. You can develop a system as a continuum. So you see one thing. In any scientific law, theory, it is always a model. You cannot describe this universe exactly. It is not possible. There are theory of uncertainty. It is in physics actually. But it is not possible. Yes. Okay. So whatever is required to us, which serves our purpose, within certain domain, it is fine. It acts. Serves our purpose. This you must keep in mind. No equation is an exact description of this physical world. It's in the knowledge of modern science or the way it progresses, even today at the highest level, that is not possible. Whatever, that is in the domain of philosophy. That part is in the domain of philosophy. Why it is possible, why it is not possible, that is beyond this thing. We have talked about philosophy before, right? Which bridges the religion and the science. Philosophy is there. What is the extent of this science? What is beyond it? Again, we have to go back to philosophy. So we are not going into it. So there is a development which is computational mechanics, which is a bit different than continuum mechanics. This should be clear to you, at least in the terminology which I am using here. What is meant by computational mechanics and what is meant by continuum mechanics. This is also required because you will see in coming years and in right now also, this computational mechanics are coming up as a separate branch in physics. In our mechanical engineering, applied mechanics, it is computational mechanics. But this can be computational chemistry, it can be computational electrical technology, anything, where the existing laws based on the continuum is falling down. Okay, so it is this computational mechanics is a subdomain of computational physics. Yes. Okay, so this is coming up in a great way. This should be clear to you. So, what is computational mechanics? Something is written here. Let us see what is written here. This is important. what it is. This belongs within computational experimentation. What is meant by computational experimentation? You see, in physics, say up to continuum mechanics, how science developed, there are two major divisions. One is theory, other is experiment. So this experiment is basically the physical observation. Like Archimedes observed whenever he is within the bathtub, some amount of water spills from the bathtub. With observation, and then he developed theory, Archimedes theory. So this is classically physics has two major divisions. One is theory and the experiment. What this theory means? What is the meaning of this theory? Okay. What is the meaning of this theory? This theory is basically a mathematical description of the physical phenomena. What we are observing in the experiment. So experiment is a repetition of the physical phenomena, and then observation of some of the parameter values, and based on that some mathematical equation is developed. So that is basically the theory which is developed from the experiment. This is classical physics. Now what happens with the advent of high-speed computers? This is what I told, starting from 50s means starting from 1950s. Okay. New element in between experiment and theory. Why this is new element? Now we solved it new element. Now the mathematical equation, how it is solved? It is not solved exactly like it was done by Timoshenko. He could model the physics of a solid body through a mathematical equation, and there was some solution of that. You see the textbook of Timoshenko. Every solution is an analytical solution. Okay. Then you go into the textbook of sense and being, etc. There, the solution of that mathematical equation is not strictly analytical. There is a numerical solution of that. What is numerical solution? Numerical solution is always an approximate solution. You see here.
Yes, sir.
And we have seen that for practical purposes, this approximate solution is good enough. It serves our purpose. We can make that approximation as close as we need. We know it is not actual,
Yes, sir.
but it serves our purpose. So we'll go with that. So, what is the natural consequence of that? In between this theory and experiment, now comes a computational experiment. There is an element bridging the mathematical equation and the physical phenomena. This is known as computer-based experiment. A new element in between experiment and theory, computer experiment, has been introduced. So whenever you are doing this, in some sense you are in computational mechanics. So that way computational mechanics is also a part of continuum mechanics. So what actually it does, so in computational mechanics, a model is still provided by theories by a mathematical model, but the calculations are carried out by computer, following some algorithm. You have to develop a program somewhere, this thing. You have to implement numerical techniques, and that is why I have emphasized on numerical techniques so much. This background must be had. Although this particular course is only theory, but you must know those things, because you might have to apply this knowledge in your particular area, whatever be there. It depends in your future course of work, what you are going to do. Okay. So there you will read this part, you will understand what does it mean, what are the benefits of computational mechanics, etc. Okay?
Yes.
So this is the last slide. So this part is clear now. So what we have discussed so far, we have discussed about introduction
History of
and then the historical development of it. The branches of mechanics, that is not much there. Anyway, we will discuss it afterwards. Okay. So tomorrow, what we will do? We will go into numerical techniques first. Let us go there and see some implementation through MatLab. Okay. Because once we start with this proper stress and deformation analysis, we must keep a continuity there. There is something more which is there. Like I have talked about these experiments, which is also need to be explained. Right? In UG class notes, this machine elements lab part, this numerical methods, this MatLab. These are the associated areas.
So how many experiments?
There are 7 experiments. Actually, you did it. You are our undergraduate students.
Yes.
But there are other students coming from other institutes. They are not aware with these experiments. Okay. So because this is the video lecture they will get. So that is why it will benefit them. Because now you have to start with sessional class also, isn't it?
Yes.
You have a subject,
Yes,
PG sessional, right?
One session also. In this session.
And PG sessional is there. So this is again prerequisite of your PG session. This one and some idea about MatLab. Okay, let us stop here.
Okay, sir. Can I stop?
Yes, stop.